So Al and Jay, I guess the next topic I really want to get into is the recent Intel and kind of AMD hardware announcements, leaks, and rumors.
Mm.
We've got a lot of kind of Intel news basically that's come out of the architecture day and some leaks surrounding that. And I've titled this one Intel Architecture for the Next Decade of Compute. Really? So look, the Intel Architecture Day is just come and gone, leaks surrounding it, and I'm just going to run through some specs that I picked up from the event.
Mhm.
So the next iteration of Intel CPU, Intel's 12th gen core, really goes by the name of Alder Lake. It's got a big little configuration, much like mobile phones. It has what they call P and E cores. P cores being Golden Cove for low latency workloads. E cores being Gracemont, which are more power limited, but also good for multi-thread workloads. But they're the efficiency cores. They're the small cores. Yeah, the idea you'll have
Mhm.
a lot of them running concurrently. Okay. Now Intel, in addition, have moved it to what they call Intel 7 node process technology, which is basically just a rebranding of their 10nm process.
Mhm.
They're trying to kind of like come in line with what TSMC and Samsung are doing. Yeah, and to be clear, the transistor density of 10nm is really comparable to TSMC 7nm and maybe even better in some circumstances, I believe. So let's roll into some of the detail. So Golden Cove, their power cores. So Intel is stating that this is their largest microarchitecture upgrade in the core family in a decade. So big news for them
Mhm.
and a way of getting them back on track and getting a bit more competitive. Certainly in the consumer space. Okay, in terms of mind share, I would say in spec. What that means it's the biggest change since Skylake, which is 14nm. We've had Skylake type architecture since 4 cores. Yeah, back in 2015 is where it came out, and again it gave us that 4 core, two-threaded, 6700K. Yeah, 6700K. They say it's 50% wider for decodes, it's 25% wider for micro ops, and it's double the capacity, 45% deeper for the out ordering execution buffer, and it just basically has really big branch prediction improvements. But really, what it comes down to is they're expecting a 19% increase in IPC, your single-threaded performance, versus Rocket Lake. Yeah, Rocket Lake. But what was unusual is that they didn't actually compare it to Willow Cove, which is effectively Tiger Lake for small form factor machines and PCs. So that was quite strange. They just kind of went desktop to desktop,
Mhm.
but really by doing that they also omitted a generation. Yeah, they omitted a generation. Okay. Now on the lower powered cores, Gracemont, this is as we know based on the Atom family of CPUs. So you're getting 1 core, 1 thread, and the comparison they did is basically with Skylake, the first iteration of Skylake. Again, comparing it to 1 core, 1 thread, and what they saw was a 40% power increase. Yeah,
Mm.
with I believe 40% less power consumption. Yeah, and then when you move on to kind of the multi-threaded use case, you had 4 cores, 4 threads for Gracemont, 2 cores, 4 threads for Skylake. Skylake being kind of obviously has multi-threading for each core, and they actually got an 80% improvement in multi-threaded with 80% less power consumption.
Mhm.
That's how they were kind of marketing the thing. Yeah, marketing the thing. All right. The
Mhm.
bottom line: better than Skylake core performance at a lower power consumption. Yeah. So to me, that's really impressive stuff. All right. Now, one thing they've done that's actually quite surprising. They've taken out AVX
Mhm.
512 instructions, which are historically there for AI number crunching and kind of just allow you to kind of work with really large register sizes and the like. Okay, and I think they've done that to allow the big and small cores to function similarly, so they can distribute workload across them. Yeah, but it's quite a big omission, since kind of Intel have been pushing that kind of instruction set for a long time. Okay. Now, what does that really mean for the consumer market? Okay, what that really means is, for desktops, you're gonna get up to 8 P cores plus 8 E cores as a configuration. For mobiles, as in laptops, you're gonna get. Hold on a second, guys. I've just been logged out my bloody notes. As I was thinking, I've got my notes written down right.
Okay. This makes my contribution of laughter.
Yeah, which is good, right? I mean, like, yeah, for laptop and mobile, it's 6 P cores plus 8 E cores. So 6 of the bigger cores plus up to 8 of the smaller cores. And for the ultra laptop space, 2 P cores plus 8 E cores. Yeah, 2 P cores plus 8 E cores. Okay, and each one of these guys has an integrated GPU. The mobile variants, 96 physical execution units for their Z graphics, and surprisingly, and I hope I haven't got this wrong, a smaller iGPU for the desktop variants. 32 execution units, which I gather they probably think that most desktop users will go with a dedicated GPU. Yeah.
Yeah.
Now, the Intel architecture is also highly modular, allows you to mix and match components, for instance P and E cores. 4 E cores take up the same amount of space on the chip die as one P core. It's basically got AI accelerators, GNA 3.0, display engines, PCIe, the mobile processors, and only the mobile processors will get a image processing unit. The desktop processor will not have any native Thunderbolt connectivity as part of the CPU itself. Those get handled by the chipset. The bigger mobile chip will have 4 ports of Thunderbolt, the smaller mobile chip 2 ports of Thunderbolt, and they support DDR5, DDR4, LPDDR5, LPDDR4. Okay, and all CPU designs can basically address all 4 types of memory. In addition to that, enhancements to PCIe. CPU supports 20 lanes of PCIe, split between PCI 4 and 5, 16 lanes of PCI 5, by 16 for GPU, by 8 for GPU, and 4 by 4 for storage. The consumer will effectively have to make a choice between using PCI 5 fully for the GPU or share it with storage. Okay, that's something that obviously people have to observe in the small print. And effectively, you get up to 64 gigabytes a second of bandwidth across these 16 lanes of PCIe 5. Okay, so all very, very impressive stuff. But I think the one thing that was super, I think, important, that I don't know that everybody's kind of either acknowledging or talking about, is the thread director. And how crucial this piece of technology is going to be. The thread director is part of the chip, and why you need it is because not all the cores are the same in Alder Lake. Yeah, it's a combined software and hardware solution between Intel and Microsoft, fundamentally Windows 11. Yeah, and what that does, it basically makes decisions on where to put threads. And what I mean by that is what cores to put the threads on. What I mean by this is that there'll be threads that require low latency, threads that require high efficiency, but are not time critical. Yeah? Because the cores aren't actually like for like. You only want certain workflows running on certain cores. So that's where the whole thing gets very complicated. And if you ask me, if they don't get this right, it could really derail Alder Lake, because you could be getting kind of really poor
Depends
performance.
on how much you can configure it, really. Unless there's some kind of analytics that it builds up over time as you use your PC, but all of those kinds of things can be very temperamental, right?
It's what they're trying to do, Mel. It's what they're trying to do. So it's a hardware software solution working hand in hand with the Windows 11 OS scheduler. So in a way, right, what they're kind of saying to us is that you only get the full benefit of these CPUs if you have Windows 11. That's what they're trying to say to us. Windows 11 will get information from the thread director to make decisions on where it puts threads. And it will be kind of runtime feedback to the OS, yeah. And it will make decisions based on workload. And it's meant to be able to dynamically kind of adapt. And it's meant to be able to use metrics like thermals, power settings, yeah. Sounds awfully complicated, doesn't it? Already, right? And,
yeah, it's introducing just another layer of just complication in the stack, which could go.
Yeah, definitely.
So certain use cases it might be good, right? But for general use,
it makes you wonder.
I'm just waiting for it to just prioritize all the Microsoft stuff, and then your gaming stack is going to get deprioritized, and that's going to work horrendously, I think.
Yeah, I know, and there is actually a hierarchy as well they put in place that I kind of observed. Check this out, right? The hierarchy and rules, on where to put threads. What it will do first, it will try to put one thread on each P call, your big calls. Yeah, it will try and fill up that scenario. So if you've got 8 calls, it will have an active thread for each P call. Then the next run down. Once that's done, it will basically start running stuff on the equals. Again, one thread on the equals. And the equals have one thread, and they're limited to one thread. And then, after the equals are full, it will start running, workload on the secondary threads of the P calls. So that's how it's kind of like filling the bucket. And again, it's meant to be monitoring each thread, doing what it needs to get out of the performance metrics, and it provides suggestions to the OS at runtime in nanosecond slices. Yeah. As a hardware fan, I'm kind of salivating. Obviously, this sounds really complicated. It sounds really interesting. But one side of my brain is telling me, damn, this is complex, right? And I hope they get this working. Yeah, I really do hope they get this working.
So or at the very least, they give us a way to configure it ourselves, because I do worry about these things. Because like on day one, it's going to be whatever they've pre-programmed, and what about new programs that are actually running? What sort of analytics they'll have on that, or is it by default just deprioritized?
Yeah, I mean they're trying to make the OS a little bit more workload aware. But as far as I know, Al, there's no way to configure this yourself. I'm sure someone's going to come out with a way to do this, because really the thread director is talking to the Windows 11 OS scheduler, which is software ultimately. I guess it's your orchestrator, your kind of workload distributor at the OS level. But thread director, in my humble opinion, is way more important for Alderlake than people are giving it credit for. Yeah. There's nothing basically for Linux yet. So I kind of wonder how that's going to work out. And ultimately, Windows 10 does not have thread director integration. It has its own scheduler that takes its cue from the hardware as well, but it's just not as sophisticated. I'm guessing it doesn't run with as many metrics. And so the question I have, what happens if Windows 11 is delayed? After all of that, what happens? And it wouldn't be the first time, right, that a Windows got delayed. And there's no fallback to Windows 10 either. What happens?
Well, you'll have a chip that doesn't perform to the best of its ability, assuming anyone that goes and purchases it. But
So from what you're saying then, Joe, this is fundamentally baked into the physical hardware as well as requiring software. So there's just no way around it. You can't turn off the software part. You're literally stuck. But
yeah,
doesn't even sound like a worthwhile gamble. Obviously, they made the decision some time back, and maybe expecting Windows 11 to come out earlier and be out in the wild and being tested for a little bit longer than it has.
It is out and about a little bit. I think people can start to upgrade. I can't remember. I think I've seen it already.
Yeah, it is out and about, but Alderlake isn't. and not out in the wild anyway. I mean, it just depends on Intel's strategy around this, because I think they made a statement saying this kind of architectural shift, this big little shift they're talking about, is going to be underpinning their designs for the next 10 years. Yeah, so you might say, like, that mean that they're willing to accept the first generation of kind of big little type chips where it's not going to work great. Yeah, well, you're not going to get the full, you're not going to get the full benefit of it, right? Because the reality is, I mean, there's going to be an element of that now, even if Windows 11 comes out on time, because Windows 10 doesn't really have that level of intelligence, to guide itself. Yeah. So it's a strange one. It's a real strange one. It feels like a gamble. When the more I think about this.
It is. You can get some. I can totally understand why that architecture would have lots of benefits, right? Using kind of less important, lower workloads on a much more efficient, lower powered CPU is a great idea. It will reduce the thermals and everything else on your PC and your power output. But it's going to add that layer of complexity, right? There's an extra step here that the OS and the hardware is probably going to have to do to work out which thread, which CPU to go to, and that's going to be like an extra little bit of input lag somewhere that I'm sure that whenever someone gets around to going testing this side by side, I'm sure they'll find something, even if it's very marginal.
Yeah, and the thinking about the kind of the benefits of this architecture, whether it be obviously you're getting more IPC. Right, so gamers are going to love that. Really at the moment, single-threaded performance is super important. Beyond that, the advantages I kind of hear about are just to do with power efficiency. Yeah, and maybe relieving the kind of peak cores to handle heavier workloads, for instance, for gaming. Yeah, but I remember one podcast we were talking about this, and you were saying to ourselves, like, could you imagine if this thing wasn't able to triage or kind of like orchestrate the threads in the right way, and like you have something like Cyberpunk running on some of these kind of like equals. It'd be like gaming Armageddon, you know what I mean?
Yeah, I mean that game is going to test anything, right? But the numbers you mentioned at the beginning around the performance boost, they don't sound, massively high. But clearly, that they can see the roadmap of somewhere down the line, a few years down the line, this is going to give them the big jumps to be really competitive, given where they are. It just seems very desperate.
Well,
yeah, I would say a 19% IPC increase, gen on gen, like they're doing, it's actually very good. It's solid, because the generations these days are kind of separated by 1, maybe 2 years. Yeah, so it's not like it used to be in the old days where, if you weren't running on the latest CPU, literally your game wouldn't run. You'd have 1 frame a second or something stupid like that. Yeah, it just wouldn't run. So we're not back there. 90% IPC increase. Very respectable, more than respectable, to be honest. But is it worth the risk? I don't think Intel have got much of a choice in it.
They don't. Yeah, so back onto your point, Jay. Yeah, it seems risky, but AMD have really pushed the boundaries. They're really pushing them on desktop and kind of laptops now. They have to do something, and this is probably their first steps into that. And I'm probably, Joe, the way I kind of see this is I'm more interested in the next generation of it. The first generation, especially with so much stuff that they're testing with Windows 11, I'm not confident it's going to work on day one.
Yeah. There's an element of that. I mean, if you look at, Zen 1 had teething problems. They kind of resolved a lot of that with Zen Plus. Then Zen 2 is what I'm on, and brilliant. And Zen 3 just kind of like, knocked it into the stratosphere. So this is where AMD's at, and they're getting much more competitive on the laptop space, which is, let's be honest, is the bigger market. But they're also getting really competitive. They've got the performance leadership in the enterprise space now as well, and that's because they're massively multi-core at the moment. And they somehow need to kind of like retain that that advantage somehow. But Intel decided to go another way for whatever whatever the reasons may be, certainly on desktop. But let's give Intel some credit here, yeah, because this is a company I'm guessing since Skylake, where they introduced 4 cores to the world with 2 threads each. They've stuck on that architecture for God knows how long. And they've had their kind of like mind share eroded. I wouldn't say market share, because to be honest, they're still king. But it's only a matter of time when that mind share turns into market share. Give it a bit, and they've got to stem that bleeding.
Yeah, the enthusiasts understand that the AMDs are already pushing that edge. Now, the brands of Intel, people still are secure, they're still happy with it, even though you're still not getting the best performance value ratio, in comparison to AMD. Yeah, it will take some time, and Intel will have to do something, and this is their kind of initial stance.
I think they've come out swinging. They're taking a risk, but that to me is a good sign, because it shows that they want to do something. You're right. They're hungry for it. They're coming across as they're hungry. They're coming across as they're saying, you know what, AMD, you're a threat, and we want to squash threats. Though I don't know if this kind of like integration with Windows 11 is the way to go, but if it works out well, But I think I think you're right, Al. The first iteration of this may not yield the results consistently that we would be expecting. I think on certain use cases, I'm sure there'll be some consistency, but potentially, it will have to evolve the software.
Typically, just how much of the success of a new generation of a chip is reliant on the chip itself, hardware and software wise, versus the actual OS? I'm just wondering.
I think it's I hear what you're saying. I think it's quite dependent on the OS to a certain degree. Only because I seem to recall that the AMD Zen chips had their own teething problems, because they were going beyond 4 cores. They were going beyond 6 cores. I think they were first to market with 8 cores, 2 threads. And even with something like that, where all the cores are the same, the OS still needs to understand it can leverage them. That they're there to be used. It's not as complicated, mind you, but it's certainly there. So it's I think it's important, definitely important, to have the software that leverages your hardware. But again, if you get to a point where the software, the OS, right, will work consistently across the board, right, and then it becomes, how far can your hardware be pushed? Yeah, we can make it work consistently.
Yeah, I mean, you probably spoke about this on a previous podcast, but at least from a perception point of view, if I look at the features of Windows 11, where they've kind of tried to really embed Android apps, they've gone with embedding Game Pass and the Xbox whole ecosystem, and they really particularly seem to be leaning into the whole gaming thing and really taking it seriously. Is not the wrong thing, because I've always been taking it seriously, but really pushing it even further, really more games focused, given that you can do so much on a Windows platform. It'd be really interesting to see how closely they've worked with Intel to really make this work from a gaming perspective, because theoretically it's got a lot of potential, right? Games are so complicated now, and you mentioned the different types of loads and complex computation that needs to happen. This sounds like it's take away the numbers of plus 20% performance or what they can gain. It sounds like it's got some legs if they can get it right. It might have some teething problems. Too much money at stake.
I mean, absolutely. I mean, like, if Intel are talking about this as this is our architecture for the next 10 years, then there's a lot at stake here. Either Intel get this working, or they're gonna lose. And I don't believe for a second that Intel will stop existing, but they're gonna lose, and they may not be the company they are today. Especially if someone like AMD, or whoever else comes on the scene, and push. I mean, AMD they just keep going.
Yeah,
it's impressive. It's an impressive competition, to be quite honest. I do hope that this actually works out for Intel. that they knock Alder Lake out of the park. The Windows 11 integration works as well as it can work. Yeah, I'm sure it will need time, but as well as it can work. Because seriously, we don't want AMD to start running away with it. If you know what I mean, because we've seen signs of that already, right? Where their kind of approach to things is somewhat different than what it was. Maybe
especially the pricing of the most recent Zen 3s, right? So you can see they're already doing a kind of almost a bit Intel-ish in their approach.
That's the thing. When you know your top, right? When you know on paper and in practice, your product is leading edge, right? Then your rational thoughts are, well, we can charge more because there's nothing on the market that competes. And this is why we need Intel to be competitive. Yeah, I mean, enthusiasts need to stop laughing at their product line. One thing, and that will give kind of AMD a slap. You know what I mean? And then they'll hopefully continue to innovate and push, and we'll get better products from them. And this is the kind of like perpetual cycle most consumers should want, if you know what I mean. Like that guy from Godzilla said in the first movie, "Let them fight." That's what you want.
Yeah, and it's good signs, I think, from Intel, and obviously we've not really touched upon it yet, but the whole 3 nanometer TSMC stuff and the GPU stuff as well.
Yeah, definitely. I mean, the free A&M stuff. I mean, I don't know if there's much of a story there. I think Intel have historically been, how they've been described is a fab with chip design. Jay, I don't know if you're close to any of this, but a fab is where you typically kind of manufacture chips. Yeah, and you give the fab your chip design. Fab creates the chips with wafers, so on and so forth. But Intel have always historically had this really big manufacturing arm to their business. AMD did as well, but they sold off Global Foundry some time ago, and they're more about chip design these days.
Kind of like how Apple operate, right? They kind of just focus on the design, outsource the.
Well, yeah, I mean that's pretty much it. But yeah, I mean with Intel, I think this whole 3nm, we're going to buy some TSMC, who are the biggest manufacturers of silicon and chips in the world right at the moment. It's about really, I think, hedging their bet somewhat, because they've had a torrid time with their 10nm chips. They just couldn't get it right. So, they're kind of hedging their bets, I think. And to be honest, I read somewhere that they've always been kind of customers of TSMC. They've always been customers. And they themselves also want to basically go down the route of providing kind of manufacturer capability to other companies. Historically, their fabs were for Intel chips or Intel products. But now they're kind of adding an extra kind of like, let's say, part to their business where they want to be like a TSMC. And part of that is maybe just the balance, balance the capacity as well. If they've got capacity here, their business could be more malleable, I kind of think.
Just a question I had is, in this Intel AMD kind of battle, where does Apple kind of sit, given they've got their new M1 chip and they're actually trying to use ARM's kind of architecture to...
Yeah, this is an interesting one.
Again, you guys are far more knowledgeable than me, but it seems they're trying to go from kind of mobile architecture into the desktop kind of probably laptop architecture first, and then I don't know, they've probably got a target to attack desktops as well.
Yeah. Al, do you want to have a go first at this? Kind of like just give your views on this one, because I've got lots of views.
Yeah, because I think we covered it in some of the updates on Apple M1, as well as the risk stuff that we kind of covered as well, right? I guess it's moving down that kind of architecture of more efficient and kind of slightly more, the efficiency of a kind of a CPU, and then actually building upon that to kind of move that further, and the whole x86 versus the sort of risk kind of CPUs, ultimately, laptop kind of markets around what Apple will do, and then it will push it further.
Yeah.
But it's good having that kind of side competition.
Yeah.
That's kind of that.
Yeah, I think it's about competition ultimately. But I will say, look, ARM didn't start life as any sort of mobile chip. ARM started life as a full-blown computer. Yeah, that's how it started. It's just it happens that ARM is an extremely efficient, architecture. Yeah, so it's obviously made its way into certain kind of areas because organically, it just was a good fit, I think. You hear rumors that Intel and even AMD are looking at Apple as true competition down the line. Yeah, true competition down the line. And a lot of that has to be because if Apple chooses to get into any domain in business area, and to degrees, same with Google, people like that, right? They're ultimately going to try and go there to win and disrupt it.
Yep.
Yeah, so for one thing. And the other part to this is that having people adopt a new variant of a CPU is, and having that ambition is all very well and good, but you need software to run on it. And the other side of this is that Linux is always run on RISC, but the Linux kind of like lovers out there will hate me for saying this, but in terms of numbers, it is a second tier OS for the consumers compared to Windows. And what have Microsoft just done? They've basically brought out a version of Windows that runs on ARM/RISC. So, I mean, why they did that themselves? I mean, I guess they were maybe kind of looking at the way that the world was kind of headed, and they have to make bets themselves. Yeah, they have to make bets themselves. But it's there. In my view, that will only get more and more mature. So people like Intel and AMD, they don't have the buffer of saying, well, Windows is an x86 operating system. Windows isn't now an x86 operating system. Windows is now a RISC operating system as well. And that, coupled with Apple getting into silicon design, because that's what they're doing, it's silicon design, yeah? That must be scaring the shit out of them. They're thinking about market share here. And whilst I think Apple work on a kind of like very much a wall, like garden type of approach, that they've got the ecosystem.
Yeah.
There's no doubt in my mind that should Apple decide they want to produce chips and sell them for whatever purpose you want those chips for, that's going to be a problem. It's going to take market share.
And just to throw a further thing, there are Chinese competitors which are slowly already doing this stuff as well. That it's not open to the kind of Western markets, so they've not really pushed it out. But they are making CPUs. I don't think they're making GPUs just yet. I know they're making CPUs, but eventually there'll be more competition that'll be out there.
Yeah, we need to talk about those guys, Al.
It is. We've got it as a topic item.
Yeah.
But
it's not for right now, but yeah, that's an interesting subject.
It's great. I mean, it's just the one thing I'll say that, and we'll say it for another time. It's crazy how they can, start producing TV screens for some, the base technology, and then in 3 years they make the best screens with the best resolution, best illumination, just the best response times. Literally anything in the last, probably since the beginning of time, right? They own everything from the stack, right? Creating the best technology now from, manufacturing everything. It's you're not able to compete. It's just a matter of time, right? Before we'll be working in the factories making chips for the Eastern market.
No, there'll be robots. Robots will do it all for us.
It's a highly automated thing already, guys. From what I understand about it.
Yeah, it must be. Yeah.
And guys, you know what? With that said, I think we should move on to the next part of the Intel hardware news, and that is their GPUs. And we've now got a product name for it, Arch. Short, sharp, and punchy.
Is it Arch or is it Arc? I would have called it Arc.
It's actually alright. Probably you might be right there. It might be called Arc. It's ARC. Yeah, ARC. Oh, actually, I would have preferred Arc.
I would have taken that as Arc.
Yeah, definitely. But it's not quite out in the open yet. The information we got for Intel was pretty much at the logical level, so logical layouts of the architecture no performance numbers, no clock speeds. So they're kind of keeping that sort of stuff close, to their chest at the moment. What we can say about this, however, that Intel have spent 2 years and no doubt a lot of money trying to enter this discrete GPU market, and they've got two variants. They've got ZHPG, which I understand, and I hope I'm getting this right, high performance graphics, and they've got ZHPC, high performance compute, which is more for enterprise, or maybe even miners. Let's not leave those guys out, right? Because we know they love their GPUs. Obviously, we know that ZLP is already available. Yeah, the LP here meaning kind of lower power. I mean, and I'm talking about, I think, energy rather than graphics performance. And these guys, Intel have got a multi-year roadmap, which I think has been, I would say, named and branded in such a way that it speaks to gamers. I'll go through this, right? They've got, the first thing that's going to come out is called Alchemist. ZHPG, ray traced graphics, DX12 Ultimate compatible, which means mesh shaders, variable rate shading, sampler feedback. But that's coming out Q1 2022. No definite date as yet for desktop and mobile. Then along the roadmap, they also have this thing called Battle Mage, right? Z2HPG, right? Battle Mage. Then after that, they've got this thing called Celestial, Z3HPG, and then Druid. They call this Z Next HPG. So what can I say? It just kind of feels they love RPGs here.
Yeah, RPGs.
Yeah.
Although I think some people make comments that Celestial isn't a type of role, because the other ones are all kind of role/character type position, but Celestial is a kind of like an area, a thing rather than a role.
Celestial, that I know anyway, I mean, it's part of the Marvel universe. Is actually a space god. Yeah, you would have seen them in, I think, some of the Infinity War saga or whatever, or in some of the Guardians of the Galaxy. That big, you saw one kind of scene where a big figure just kind of like hit the ground with their staff, and then everybody died on the planet. That was a Celestial. Yeah, I'm an ex-comic geek. Yeah, this is why I kind of know this kind of shit. But I'm an ex-comic geek. So yeah, I mean, Arc is really kind of shaping up, and it's the brand name, kind of like Radeon, kind of like RTX or GeForce. Rolling into some of the specs, right? Let me just try and be kind of quick about this, right? Intel are no longer using EUs or execution units. These execution units are about computing shaders, okay? But they're talking about them. They renamed them, and they're calling them Z cores. Yeah, Z cores. Yeah, each Z core can have 16 vector engines, and each can process 256 bits per cycle. Okay, so that effectively 128 floating point 32 ops per cycle. Yeah, it's effectively an arithmetic logic unit. In conjunction with that, they also have 16 matrix engines. Each can process 1024 bits per cycle, which is in effect is 64 FP16 operations per cycle, or 128 int 8. And why I'm talking about int is these are effectively tensors. These are effectively tensor-cores, because with AI processing, you talk about int rather than FP. Okay, and it looks like to me they're dedicating more silicon to neural net and AI processing in the shape of these matrix engines, even more so than NVIDIA, which is quite interesting. And hence we've got this Z super sampling. Okay, these Arc CPUs are also organized into they call render slices. So each render slice can have 4 Z cores, 4 ray trace units, 4 texture samplers, and these geometry and raster front ends, pixel back ends. And Alchemist can have up to 8 of these slices. I guess that would be their top card. They could occupy all 8 slices, and obviously it kind of like goes down depending on low or medium end GPUs. Yeah, it sounds like it's for scaling the product. Yeah, and these slices also communicate via a fabric, which is very kind of AMD-like. The fabric contains L2 cache. They're rumored to have DisplayPort 2.0 support, and they would be first to the market if this happened. And they're using TSMC 6nm process, which I guess could be also a first. They have power per watt improvements over the existing Z LP GPUs they have. They have estimated clock speeds of up to 2.4 gigahertz, which sit somewhere between AMD and Nvidia. AMD being a little bit higher, Nvidia obviously a bit lower. Based on some of these assumptions and predictions, we're talking about 18.5 teraflops of FP32 compute if we're using all 8 slices. Okay, and how that compares to AMD and Nvidia, I'll tell you as soon as I log back into my notes again. So the AMD 6900, their top end card is approximately 23 teraflops. The top end Nvidia card 3090 is 35 teraflops. And to be clear, guys, I mean a teraflop is it's no kind of like super accurate way of kind of gauging graphics performance. This is purely compute. There's other factors obviously as well, but it gives you a sense of where they lie. Yeah. So there you have it. I mean those are the information that was delivered, the stats they've provided. I mean they haven't gone deep into the specification. I will say that Z's super sampling actually looks super impressive. It actually looks as if it does more than, let's say, Nvidia's DLSS, but they may have better adoption with it because it will work on other types of graphics card. So it's an interesting place they put themselves. Yeah, and I guess what I kind of think when I see all of this is that will this drive competition? I think the answer has to be yes. Yeah, but will Intel price these things to either push AMD and Nvidia to be a bit fairer of their pricing, or will they come into this market and say, you know what, I like our product, so we're just going to price it in a similar way to both kind of AMD and Nvidia. We're not going to try and undercut these guys. Our product's too good for that. And again, could Intel, if they're being smart and savvy about this, could they win this GPU market at least for the short term? That's what comes into my mind. I mean, I think the old Intel would have just said, yep, we're just going to price it the same as AMD and Nvidia. We're not going to try and undercut these guys. We're not going to try and give it any more value. Our products are too good. But with where Intel are now, I would be super surprised if they didn't.
Have they mentioned any extra boost by using their Intel CPUs with that as well? Or?
Not yet, but I think that's on the cards. I think you have AMD who have their A+A, and I'll be surprised if Intel didn't have a similar thing with I+I.
I would expect so at some point, but it's one of those. I think even just based on the metrics you covered there, Joe, I think it really does depend on which market they're going for, right? I suspect they won't be going after the sort of main gamers. I suspect they'll package it with their kind of Intel kind of chipsets and go for kind of laptop market. That's my guess, but we'll see.
I think that they definitely will go after the laptop market, no doubt about that. But I think, looking at the kind of noises they're making, I think they will try go the desktop discrete GPU market. Mm-hmm. The kind of power level they're talking about, the fact that they're talking about ZSS, they effectively come out with a card that, in terms of feature set, has immediate parity. If you know what I mean, it has immediate parity. There's not a feature here that's missing yet, obviously, and DLSS and FSR being so much in the kind of news at the moment, they've immediately said we've got our own variant of that, and it sounds good. So I'm hoping they're in it to win it, because GPUs are still frighteningly expensive.
Yeah,
for what they are.
Like this happens in a lot of industries, right? To take a bit of a sidestep, like cars. Like it's very hard for a new manufacturer to come from nowhere, right? And Tesla have seemed to have done it, but they've reinvented themselves they reinvented the industry and entered the market at the same time through electric cars. This scenario is very different, right? Because you've got the whole ecosystem of monitors and the different types of sync and games being built, consoles and games for PC and consoles all kind of being tweaked for certain hardware. All of these players going to join the ecosystem. It's almost like it's an upward hill they're pushing against, aren't they? It's not just a parity of performance or a cheap price that's going to win it from them. There needs to be a pull from the other side that isn't just consumers, it's suppliers as well.
Correct. What I will say to that is Intel have got a lot of money. Number 2, they've got a lot of partnerships. And number 3, they've actually already got GPUs out in the wild. They've got so many integrated GPUs out in the world.
Yeah, that's true, yeah.
Right? They're not actually as behind with, let's say, drivers and software as we might think.
Yeah,
so they've got the some fundamentals there. So I just think, they are new, but they're not so new that, it's not like somebody starting for a fresh. It's like, it's kind of like someone who, and taking your car analogy, who has
it's probably like you're a basic kind of consumer, car manufacturer, but then you're gonna go you're gonna go into F1 and go racing. But it's similar, right? But you just gotta up the game, I guess, around it.
Correct. We make family cars, but we're now gonna basically create a supercar. But you've still got people who know about cars.
Yeah.
So you know what I mean. So it's a little bit different.
It's a fair point, and again, you could probably shoot me down here, but it's probably arguably harder to make an integrated CPU and graphics card than it is to have a discrete one, right? It's probably more
potentially. I mean, potentially, because you've got a lot less kind of die space on the chip to work with, and real estate is, I guess, quite important. But equally, I don't think people have any sort of kind of real expectation when it comes to integrated graphics. Whereas if you create a discrete graphics GPU, they are all over you. You know what I mean? Like they're benchmarking this stuff to hell.
Would you buy one? What would be the reason? What would be the reason that either of you would buy one?
That's an interesting point, actually. Do you know what? I've got to say I'm actually quite excited with what Intel are doing. No, I don't think I'm necessarily. I mean, my view was I was going to go all AMD at some point, especially if kind of RDNA 3, the next iteration of graphics card was going to be as good as they were saying it was going to be, or maybe even RDNA 4, because that timing wise that would have been the right time to kind of upgrade. Not right now, because I'm not really going to do anything with it. But looking at what Intel are doing, for me I'm a bit of a tech head, and so when I see some of this stuff, I mean, I probably think first about, wow, look at the specs. Look at this. This is clever. Look at that. That's clever. I don't really actually think about what it's actually going to do for me. Yeah.
And that's where I come in, because I similarly get interested in this stuff, right? Not to the level of depth that you guys do, and I don't have technical knowledge, but I do get excited by power and performance and cost and that sort of thing. But where I love my consoles because it's just simplified and you get far less issues. I mean, I know that's completely changed. That's probably like an old view, but it's all down to the use case, right? Even if a game is better on a PC with 30% better graphics, it doesn't really change the gameplay, and things are getting so good now, photorealistic. It'd be interesting to see what if you were to say to me that these new Intel chips and graphics cards change the dynamic, that the developer could make different mechanics because the processing's done in a different way, right? An example being, we've got these solid state hard drives that the game designers are changing how you load into another level. Rather than fill a bit of content, they can just go straight into it. If there was that type of equivalent for the chips, right, and it had a meaningful use case, then I think it would be good. But I don't quite, and these guys all struggle to come up with a use case in the same way with a lot of AI, machine learning stuff. All this stuff is changing now, but it's all hyped, and even VR to an extent.
Yeah.
And the use cases haven't really come along.
I hear you. I personally think, and I'm thinking more of Intel GPU than CPU. I personally think that Intel's secret weapon will be more AI based, more so than Nvidia and AMD, just by the amount of silicon they put in these things, and just from the perspective of the kinds of things they've done for AI in their recent past. Yeah. Now, what people choose to do with that technology is another thing, because AI is a bit of an open book at the moment. It's really about, it's a bit like the not quite the Wild West, but it's you're just exploring a new continent almost.
Yeah.
But I kind of feel that that's where Intel's advantage, if there is any, will be. Because it just feels like, I'll give you an example, right? Z supersampling versus DLSS versus FSR. FSR spatial, yeah, not really anything to do. There's no AI in it, so it's kind of fairly good algorithm, but not that sophisticated in comparison. DLSS, I think, takes 16 samples of a pixel. What that means, I think it's about like sampling the history, if you like.
Yeah.
ZSS is taking 64 samples. Yeah. And my thinking is, in order to accomplish that, right, you must have enough silicon to do that quickly. Yeah. Because at the end of the day, right, doing all this stuff, there's an overhead, and you don't really want to tank the frame rate. So it just makes me feel that, they've invested a lot of money in some of this kind of AI tech, and if kind of developers could leverage it, that would be amazing. I mean, I hear even in Insomniac on the PS5, right, leverage some sort of AI tech for the animation for the new Spider-Man. Yeah, and in comparison, I'm imagining the PS5's hardware is quite low powered for AI. Yeah, so it's kind of all these things. It's like the it's an uncharted continent that people have got to basically just start to explore.
Yeah.
But I'm kind of excited at giving you a lot of silicon, potentially giving you a lot of silicon to kind of explore it.
Yeah, it will ultimately depend on the outcome of all the performance tests that go with it, right? For the various workloads,
Yeah,
what is it going to be good for, and then the price, and then when you compare it against Nvidia's offering and AMD's offering, then it may be competitive. And there's plenty of Bitcoin miners still out there that are still buying up these GPUs, right? So
Correct.
even if Intel fulfills that market, at least they'll ease up some of the other market that we've got. So it will ultimately depend on the performance and price ratios of these things.
Correct. I think. Guys, with that being said, and looking at the specs and what Intel have been able to do so far, and I should say able to communicate. My hope is that they're super competitive, three-way dance between Intel, Nvidia, and AMD. That can only be good. Yeah, I mean, back in the day, right, there were loads of companies, entities who were in the GPU market. Was it Matrix, Voodoo, 3DFX, Nvidia, ATI, which is I think it's now AMD. So there were so many, right? And that was a period of really big innovation. Yeah, that's what we kind of want to see.
Yeah.
Let's have that back. And Apple, if you want to make a GPU as well, go for it.
Yeah.
I don't expect them to compete on price though.
No, probably not. It'll be a luxury item.